There, Mr. Sutton here, bringing you the Algebra 2 4-5 Part 2 homework solutions on solving polynomial equations. In this one, we're focusing on using our solving skills to graph polynomials in standard form. For this problem, we're trying to graph the p function here. So one thing I'm going to need is the x-intercepts for this thing. Let me start by setting this equal to 0 and solving for the roots, which are the x-intercepts. Now, when I'm doing this, I notice that all of these have a common factor of x to the fourth that I can take out. So let me do that first. That leaves me with x squared minus 11x plus 30. And then I bet I can factor the stuff inside here a little bit more as well. Things that multiply to 30 and add up to negative 11. We got 1 and 30, 2 and 15, none of that's working. 3 and 10 doesn't work. 5 and 6, that works if they're both negative. So I've got the x to the fourth, I've got x minus 5 and x minus 6. Setting each of these equal to 0 and solving, we have x equals 0 for that x to the fourth, and then 5, and then 6 minus 6 zeroes out that last one. And I'll put all this on the graph after I've done my analysis here. I've got a few more things I want to find. The next thing I like to look for is the y-intercept. We have an invisible plus 0 here for the constant, and you would get 0 if you just plug in 0 for x. So we have a y-intercept of 0, 0, which is the same as the x-intercept of 0, so that's not going to really give us anything new. And then let's talk about lead behavior, end behavior. Our lead term is x to the sixth. That is a positive x to an even power. So that means we have an up parabola kind of shape to this thing. It's going to start and end on an upswing. And then finally, looking at our root behavior, we have an even power at 0 and odd powers that gave us the 5 and the 6 roots. So because we have an even power at this x to the fourth, that means at 0 we're going to be bouncing, and the odd powers at 5 and 6 mean we're going to be crossing at those x-intercepts. So let me do my x-intercepts now. We've got 0, 5 is somewhere over here, and 6 is a little bit further to the right. Y-intercept, again, we've already accounted for with the x-intercept at 0. And we're going to be starting above our first point and coming down and bouncing off of 0, then coming back up and crossing through 5, coming back up, crossing through 6. And our graph ends on an up note, which is where we expected it to end. For this problem, we're going to try and sketch the g function. So we're going to get the x-intercepts, y-intercepts, the end behavior, and the root behavior out of this function, and then we'll put it all together on the graph. First thing I'm going to do if I'm solving for the x-intercepts is I'm going to basically set this equal to 0 and try to factor and solve it. One thing I'll look for is common factors. Now these are all divisible by 2, and if I'm going 2, I might as well take out a negative 2. And also x to the third is the lowest exponent, so I can factor that out as well. So I'll start with a negative 2x cubed coming out of there. This first term now is going to become an x squared if I divide negative 2x to the fifth by negative 2x cubed. So x squared. And then 2x to the fourth divided by negative 2x cubed is going to be a negative 1x to the first. And then finally 40x cubed divided by negative 2x cubed is going to be negative 20. I can factor the stuff inside here a little bit more, so let me bring down this negative 2x cubed just so I don't forget about it. And in here now, numbers that multiply to negative 20 and add up to negative 1. Well, 1 and 20 doesn't work. 2 and 10 is no good. 4 and 5 works if I have a positive 4 and a negative 5. So there's that factorization. Setting each of these factors equal to 0 and solving now, if negative 2x cubed equals 0, just plugging in 0 would zero out that whole first factor. So we have x equals 0. And then negative 4 zeroes out the next factor, and 5 gives us a 0 on that last factor. The y-intercept is the invisible constant of plus 0 over here. That's the same as the x-intercept of 0, so no new material there, but that's okay. We'll just keep going. The end behavior, we start with a negative 2x to the fifth for our lead term. That's a negative x to an odd power. That's going to be a down line. And then for the root behavior, the 0, the negative 4, and the 5 are all coming from odd powers. We have third power, first power, first power. So we're going to be crossing through all of those. Although if we're being technical, we could say we're flattening at 0, but let me just write cross. There we go. So crossing through all of them, just so we're not muddying the waters. But I'm just going to keep in the back of my mind that if I'm being super fancy, I could flatten as I cross at 0 because we have an odd exponent higher than 1. Whether you actually put that in your graph or not, that's up to you. So graphing out my x-intercepts, we've got -4, 0, and 5. The y-intercept of 0, 0 is right here. We've already done it. We're starting above the x-axis and ending below the x-axis based on this end behavior. And we're going to be crossing at all 3 x-intercepts. So starting up here, crossing through -4, crossing, and if you want, flattening through 0, coming back down and crossing through 5. We end below the x-axis just like we said we would. To graph this one, let's first factor this out so we can find the x-intercepts. Since we have fourth power, second power, constant sort of pattern going on here, this one's in quadratic form. So we can treat it like a quadratic, only we'll use x squared instead of x when we factor this thing out. So since I've got 81 and 18 here, let me think of numbers that multiply to 81 and add up to -18. So that would be, I think, -9 and -9. So instead of writing x minus 9 quantity squared, I'm going to write x squared minus 9 quantity squared. And if I want, I could actually split this up a little bit more. One of these would go into x plus 3, x minus 3. Since I have 2 of them, I can just do x plus 3 squared, x minus 3 squared. And now setting each of these equal to 0 and solving, we see that x equals -3 for this first one and +3 for this other one. Let me get a little bit more information now. The y-intercept is going to be this constant of 81 over here. So 0, 81. For the end behavior, we have a lead term of x to the 4th. That's a positive x to an even power. That means that I'm going to have an up parabola sort of look. We're going to be starting and ending above the x-axis. And then finally, for the root behavior, both of these zeros, -3 and 3, are coming from squared factors. So that means that we're going to be bouncing at both of those spots. So putting it all together, let's do our x-intercepts, -3, +3, and the y-intercept, 0, 81, somewhere up here. We're just sketching it. And now we're starting, we said, above the x-axis, and we are bouncing off of -3, going through the y-intercept, coming back down and bouncing off of 3, and then going up forever, just like we said we would. We're going to go ahead and graph the p function now. In order to do that, we want to get the x-intercepts, so we're going to try to solve this by factoring, set it equal to 0 and solve it. So since I have 4 terms and there's no common factors I can take out of everything, I'm going to go straight to grouping. For the first 2 terms, I can take out an x squared. That leaves me with an x and a -5. For the next 2 terms, I can take out a -4, leaving me with an x and a -5 there as well. So now this x minus 5 is a common factor that can come out of everything. And then x squared minus 4 are the leftovers. Going a little bit further, we can split this x squared minus 4 up into x plus 2, x minus 2. And now our zeros, we're going to have 5, -2 for this plus 2 here, and +2 for the x minus 2. For the y-intercept, we've got this 20 over here, our constant. And then for the end behavior, the lead term is x to the 3rd. That's a positive x to an odd power. So that's going to be an up line kind of end behavior, starting low, ending high. And then for the root behavior, all of our zeros are coming from one power, single power, odd power factors. So we're going to cross through all of those. So starting below the x-axis, well actually let me do my zeros first. So we have -2, 2 and 5 somewhere over there. Y-intercept of 20 somewhere up here. And now starting below the x-axis, we're going to cross through -2, go through the y-intercept, cross back down through +2, turn around, cross through 5, and going up there matches the end behavior that we predicted earlier.